welcome to home school. This is your class 10 Mathematics NCERT or CBSE board. We are in our last chapter, that is chapter number 15, surface areas and volumes. As we have discussed in our previous classes, in class 9 we have studied surface areas and volumes. It is just the continuation part from 9th to 10th. Whereas in 9th, we have studied about every solid. What is a CSA? What is a TSA? What is its volume? In 9th, we have studied about the basic formulas of each and every solid. That is cone, cylinder, cube, cuboid, sphere, hemisphere. These all we have discussed, right? In this year, we are going to see the combination of solids and conversion of solids. Combination of solids. So let us take a hemisphere surmounted by a cone. Hemisphere and cone combinedly we are going to get as a solid. Combination of two solids, I am going to frame a problem. Similarly, a capsule, if you take, what is that capsule? It is a combination of one cylinder and two hemisphere joined at the corner of the cylinder. Similarly, tent, circus tent. What is the combination of the solids we use? Cylindrical at the bottom and cone is placed on the cylinder. Like this, two or more solids combinedly we are going to find the surface areas or total surface areas or volumes. And we are going to learn one more new solid, that is here, frustum of a cone. We are going to learn one more solid in this year, that is frustum of a cone. And in this year, we are going to do some problems regarding the conversion of solids. Conversion of solids means, suppose let us take a cylinder. Melt that cylinder to small spheres or melt that cylinder to small cones. Having so and so radius, they may give you. When you are melting, the volume doesn't change. Is it changes? No. Volume of cylinder is equal to volume of small spheres. We are going to apply those formulas. Before going into the chapter, we are going to have a recap of what we learnt in 9th standard. We have learned about all the formulas and have to draw the solids and how to identify lateral surface area, curved surface area and total surface area. So in our introduction class, we are going to discuss those basic concepts. Let's start. You can see some points I have written on board. Figure, shape, dimension, CSA or LSA. What is CSA full form? Curved surface area or lateral surface area. TSA, total surface area and volume. We are going to consider one by one solid and we are going to write all the formulas. Let's take the first figure, cube. Look here, this is cube. What does it have? It have faces, edges, vertices. Let's start counting here. 1, 2, 3, 4, 5, 6. How many faces a cube have? 6 faces. How many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A cube have 6 faces and 12 edges. Okay. And how many vertices will it have? 1, 2, 3, 4, 5, 6, 7, 8. 8 corners. These are the vertices. What are edges? When we join these vertices, we are going to get the edges. And these are the faces. Have to draw this on board. It's very simple. Draw a square and one more square inside the square. Join the corners like this. This is cube. This is cube, right? It has top, bottom. Let us shade top part and bottom part. It is a three-dimensional figure. Cube is a three-dimensional figure. But all sides are equal. Let us take its side as A. A units. Now, dimensions. What are the dimensions we use here? It is a three-dimensional figure, but all sides are equal. Let us take side is equal to A. Next one, CSA or LSA. For cube, the faces are lateral. So, we call it as a lateral surface area. How do we get lateral surface area? Other than top and bottom. How many faces it have? 4 faces. Let us split this one. Let me cut the cube here and then open the box like this. Look here children, easy to understand. 1, 2, 3, 4. Okay, these 4 sides are only called as the lateral surfaces. Suppose if we are in a room, all the 4 walls we call it as a curved surface area. Only for lateral surface area we consider the 4 walls area. Having each side A. What is the area of this square? A into A square. And this square, A square, A square, A square. Right? Lateral surface area of a cube. Add all these. What you are going to get? 4A square. Lateral surface area of a cube is 4A square. Square units. Always area we write with square units. Next, total surface area. How to consider total surface area? Lateral surface area plus top plus bottom areas. How we can split this cube? 1, 2, 3. This is lateral surface area. Already we found it as how much children this one? 4A square. And it has top square and a bottom square. Yes, if we open the box, we get a top piece and also a bottom square. Both are squares. Then what is the area of this square? A square. And what is the area of this square? A square. A square plus A square. 4A square plus A square plus A square. It will be how much? Let us add this. 4A square. Lateral surface area plus top area plus bottom area. It will be 4 plus 1 5 plus 1 6. 6A square. 6A square. Square units is the total surface area of a cube. Coming to volume. What is volume? Have to remember easily. Volume is always base area. Base area into height gives the volume. So if I consider this cube, base area, it is a square. So what is the area of this square? It is A square. All sides, all dimensions are equal here. Then what is the height of this cube? Height of the cube is also equal to A. Yes, and all sides are equal. This is A, this is A, and this is A. Therefore, base area is A square into A. That will be A cube, cubic units. Volume always we need to write in cubic units. So finally, what is the lateral surface area of a cube? 4A square, square units. Total surface area of a cube? 6A square, square units. Volume of a cube? A cube, cubic units. Now sometimes there is one more question they may ask regarding this cube. What is the length of the diagonal of a cube? How can we get a diagonal in this cube? Yes, we are going to get. How? Look here. From this corner, from this point to opposite bottom corner. See here, where I have kept my fingers. From here to here, if you draw a line, that is called as a diagonal. Like this, you can join the diagonals. What is the length of that diagonal? So you need to remember the formula, that is diagonal length. Diagonal length is equal to root 3a or a root 3. You can remember. What side if you take, that letter you have to choose here. Suppose you have taken x, you can take it as x root 3 or root 3x, anything is okay. So coming to your next solid, that is cuboid. Second one, cuboid. Have to draw this cuboid. Look here. Is this a cuboid? Yes, it has a rectangular faces and square faces. You can see here, rectangular face, 1, 2, 3, 4. It has 4 rectangular faces and 1, 2 square faces it have. Total how many faces this cuboid have? It also have 6 faces. Whereas cube is also having 6 faces. But here 4 faces are rectangle and 2 faces are square. How many edges? Count here how many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. How many vertices? 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8. Both will be having similar, but other than rectangular faces, remaining all same. Have to draw this on board. Draw a rectangle and draw another rectangle little bit inside the rectangle. So now join the corners. You are going to get a cuboid. Yes, you are going to get a cuboid, and whereas cuboid is a 3-dimensional figure, 3-dimensional solid, that is length, breadth, height. L, B, H are the 3 dimensions we use. Let's write here. L indicates length of the solid. B indicates breadth. H indicates height. Yes. Now we are going to calculate what is lateral surface area of a cuboid. What is lateral surface area of a cuboid? So look here. Square face, rectangular face, square face, and also rectangular faces. Means sum of 2 rectangles plus 2 squares give you the lateral surface area of a cuboid. So let us cut it one part and then split the faces. Look here. Square, rectangle, square, and a rectangle. Yes or no? See, I have cut it here. Square, rectangle, square, rectangle I got. Now, we need to write the dimensions for each piece. Look here. If this is square, what you have? Breadth and height. Breadth, height. And if it is a rectangle, what is the dimensions it is having? L and H. This is L and this is H. Again square, breadth, height. Rectangle, length, height. Okay, area of this each piece you are going to find now. Area of a square, actually it is a side square. When all sides are equal. Here all sides are not equal. But whereas this height is equal to breadth. So, B into H we need to write. Area of the square is BH plus area of this rectangle. What is this rectangle area? Length into breadth. So the two dimensions, what you can see? L into H plus square BH plus rectangle LH. Now add these two. 2 times BH plus 2 times LH. LH plus LH, 2 LH. Now take out common. 2 into B plus L you can write, or L plus B you can write, into H. Or you may write 2H into L plus B also you can write, no problem. What is the lateral surface area of a cuboid? 2 into L plus B into H square units. Okay, coming to total surface area. Total surface area. Look here, this is the top shaded region and this is the bottom. Lateral surface area plus top area and bottom area. Top is a rectangle and bottom is also rectangle. So look here carefully. First you need to write lateral surface area of a cuboid. 2 times L plus B into H plus, what is this top area? Length into breadth. Length into breadth means, what is the area of this rectangle? LB. And this rectangle, LB. Plus LB plus LB. That will be, if you want, you can just remove from brackets. 2LH plus 2BH plus LB plus LB will be 2LB. Now in all these three, something is common. What is that? 2. 2 into, instead of writing LH, BH, LB, I start writing from here. LB plus BH plus LH or HL is same. Have to remember this formula easily. 2 times LB plus BH plus HL square units. Lateral surface area of a cuboid is 2 into L plus B into H, and total surface area of a cuboid is 2 into LB plus BH plus HL square units. Coming to volume. Volume, area of a base into height. What is area of a base? LB into H. LB into H will be LBH. Let's write here. LB into H. Length into breadth into height, that will be LBH cubic units. Okay, is this clear? Lateral surface area means only outer ring, and total surface area means outer part and top plus bottom. Volume, the quantity, what it contains. Volume, the space or a region which is contained by this cuboid. That is the volume or the quantity you can store in this solid. Volume of a cuboid is LBH cubic units. As we have seen one formula for cube, that is how to find the length of a diagonal in a cube. That is root 3a. Similarly, we are going to calculate the length of a diagonal in a cuboid. What is the formula here? Diagonal length of a cuboid is equal to square root of L square plus B square plus H square. The diagonal length here, children, diagonal length of a cuboid is square root of L square plus B square plus H square. Let's see the next solid, that is right circular cylinder. Right circular cylinder. Right circular cylinder. So you can see here, this is a right circular cylinder. How it is, children? It is a curved face. It is not lateral. It is a curved face. Right circular. This is circular cylinder. Why it is right circular? Means it is a two-dimensional figure, whereas the radius and the height are perpendicular. So we call it as a right circular cylinder. This one, let's draw on board. Draw a circle. Draw a line like this and one more circle. So you can see here children, this is the radius and this is the height. Radius and this is height. Radius and height are perpendicular to one another. So we call it as a right circular cylinder. How it will be? It will be having a curved face. When we talk about curved surface area, only this area we are going to calculate. When we talk about total surface area, curved surface area plus area of the circle at the top and area of the circle at bottom. Let's see here. And what are the dimensions we use? R. R indicates radius. H indicates height. Radius, height. Now, curved surface area. How to understand this? So, in order to understand curved surface area, let me take a rectangle. Okay, let me roll this rectangle. Okay, fine. What is the area of a rectangle, children? Area of a rectangle is length into breadth. As we know, area of a rectangle is how much? Length into breadth. Now, this rectangle, I am going to roll it as a cylinder. Just look here carefully. See, I have joined the two edges. Which shape it is? It is in cylindrical shape. Yes, this is a curved face and this is the bottom top. How it is? Now, how can you calculate the area of this cylinder? As you know, length into breadth you have said. This is L, this is breadth you said. When you roll, what happens? This becomes circumference of a circle. What does the length become now? Circumference of a circle. What is circumference of a circle formula? 2 pi r. So look here. 2 pi r into circumference of a circle into height. This is only length into breadth. Length, when I roll, length becomes circumference of a circle. 2 pi r, breadth is height. That means 2 pi r into h. That will be 2 pi r h square units is the curved surface area of a right circular cylinder. When I talk about curved surface area, only this curve I want. Now, when we talk about total surface area, CSA of a cylinder plus area of this circular base and area of this circular base. Okay? Now, right here in total surface area, 2 pi RH, 2 pi RH plus area of a circle what? Pi r square. Area of a circle pi r square and area of bottom circle pi r square. Pi r square plus pi r square will be 2 pi r square. 2 pi RH plus 2 pi r square. Now, is there anything common here? 2 pi r is common. Take out common 2 pi r into h plus r. 2 r's you have, 1 r you take out common. 2 pi r into h plus r you can remember, or 2 pi r into r plus h square units is the total surface area of a right circular cylinder. Coming to volume. What is volume? Area of a base into height. Area of a base. Base is in which form? Circular. Yes or no? Base is circular path. Area of the circle is how much? Pi r square into height. That will be area of a circular base pi r square into height. That will be pi r square h. Cubic units is the volume of a right circular cylinder. Let's see the next solid here. That is right circular cone. Right circular cone. Let's draw a cone. Circle at bottom. Why it is right, children? Here also radius and height of a cone are perpendicular to one another. So it is right circular base it have. So it have right circular cone. Right circular cone. This is a solid for right circular cone. You can see a circular base at the bottom and it has a vertex. Okay, from here to the center of the circle is height. Then what about the slanting part? We call this as a slant height. Radius, height, slant height. Height is represented by small h and slant height is represented by small l. What are the dimensions we use here? R. R indicates radius. L indicates slant height. And one more. What is another dimension we are using here? H. H indicates height. Now, in this cone, what is a curved surface area? This is a curved surface area, right? Have to find the curved surface area. It is half of a circumference into height. What is circumference of a circle? 2 pi r. Half of 2 pi r will be pi r. Pi r into slant height, that will be pi r l. So write here curved surface area of a cone. Pi r l. You can remember it as half of the circumference into slant height also you can remember. Or directly you can say pi r l square units. When we talk about total surface area, total surface area means curved surface area plus area of the circular base. You can see here this area and curved surface area comes under total surface area. In total surface area, we write first curved surface area plus area of the base, that is area of a circle. What is area of a circle? Pi r square. Take out common. Pi r is common. Pi r into l plus r you can write, or r plus l also you can write. Pi r into r plus l square units. When we come across volume of a cone, what is volume of a cone? It is 1/3 volume of a cylinder. What is volume of a cylinder? Pi r square h. 1/3 its volume is cone. So write here 1/3 volume of a cylinder. 1/3. 1/3 of a cylinder is volume of a cone. So it is 1/3 pi r square h cubic units. Coming to next solid, it is sphere. See next solid children, you can see this, all are familiar with this solid. It is a sphere. Which shape it is? Circular shape. Does it have a lateral surface area? No. Curved surface area? Yes. What is the total surface area? See here, either it is a curved surface area or total surface area. Both it will be having same. Means only one surface area it have. Either if they ask for CSA, same formula. And if they ask for total surface area of a sphere, same formula. Let's draw this on board. Sphere. Which shape it is? It is in circular shape. Okay. It has radius. One dimension is radius. That is R is equal to radius. What is the surface area? Surface area of this sphere. 4 times area of a circle you can remember. What is the area of a circle? Pi r square. 4 times area of a circle is surface area of a sphere. That will be combinedly either it is CSA or TSA. It is 4 pi r square. Square units is the surface area of a sphere. Surface area is 4 times area of a circle. Then coming to volume, we remember it as 4/3 pi r cube. Remember here children, here radius cube will be there. 4 by 3 pi r cube cubic units is the volume of sphere. Now coming to next solid, it is hemisphere. How we get hemisphere? See here, this is sphere, hemi. Half of this sphere, you are going to get hemisphere. How many hemispheres you can do? 2 hemispheres, right? Let's see the hemisphere now. So have a look. This is the hemisphere. Okay, how it is? Curved surface area and it has TSA. Whereas a sphere doesn't have any separate total surface area or a curved surface area. It is having only one surface area, or both surface areas will be same. CSA or TSA is same. But whereas in hemisphere, it is different. It has a CSA, and also when you cut it, you are going to get a circular region at the top. CSA is this one. When total surface area we need to find, CSA plus area of a circle, you are going to get the total surface area of a hemisphere. Let's write down here. Next solid, hemisphere. How do we draw? Like this, circular and like this. This is the way we draw hemisphere, and it has radius r. Radius r. What is the curved surface area of a hemisphere? Curved surface area of a sphere is 4 pi r square. When I cut it out, the half region will be there. That means half of this is hemisphere curved surface area. 4 pi r square by 2. It will be 2 pi r square. What is the curved surface area of a hemisphere? 2 pi r square. Total surface area, curved surface area plus area of a circular path, that is pi r square. 2 pi r square plus a pi r square will be 3 pi r square units. Next, when we talk about volume also, half of sphere volume we are going to consider. What is the volume of a sphere? 4 by 3 pi r cube. Then half of it, you just multiply half for this. Half into 4 by 3 pi r cube. R cube, 2 2s are 4, it will be cancelled. Then your answer is 2 by 3 pi r cube is the volume of a hemisphere. Let's see the next solid. What is your next solid? It is frustum of a cone. What is frustum of a cone? So look here, this is cone, right? Circular cone. When it is cut out, this piece is cross section here. Let me remove the part. So look here carefully. When this part is removed, what the solid you get, that is called as a frustum of a cone. In a right circular cone, top vertex part is cut out. So we call this solid as frustum of a cone. So this part is cut out, children. So this is the frustum of a cone. How it will be? Curved face, a circular base, and also circular top. This is a small circle and this is big circle. You are going to get. So example of this frustum of a cone. Let us imagine bucket. What you get in your home, bucket, reverse bucket, you can imagine. Frustum of a cone. What is this frustum of a cone? Let me draw a cone. Look here carefully, children. This is cone. Then where is the frustum of a cone? If some part of the cone is cut out. Look here carefully. This part, if you remove, so-called figure is called as a frustum of a cone. For this easy example, you can consider a bucket. Reverse frustum of a cone. Small, bottom it will be having small circle, and at the top you will be having a like this. Look here children, like this you can imagine a bucket. Yes, what you see every day in your home. This bucket is an example for frustum of a cone. Yes, is this clear? How do we get a frustum of a cone? When vertex part is cut out, when some part of a cone is cross-sectioned, then we get a frustum of a cone. Then it has two radius, not only one, two radius will be there. Small circle, let us take small r. Big circle, let us take capital R, H, and also slant height L. So I forgot one step in right circular cone. Let us deal that one. When some problems they won't give slant height, you need to calculate slant height and find the curved surface area. How can you find out slant height? There is a formula, that is L square is equal to H square plus R square. If you want to calculate only L, this square remove. When you remove, you are going to get square root. Square root of H square plus R square. Slant height L is equal to square root of H square plus R square. You should remember the small tiny formula. And now coming to frustum of a cone. What are the dimensions we have here? Small r. Radius of smaller circle. H indicates height. Small h indicates height. Capital R indicates radius of bigger or a larger, you can say, larger circle you can say. Small r, capital R, H. Curved surface area of frustum of a cone. What is curved surface area of a cone? Pi RL. Similarly, frustum of a cone, pi RL. R is what? Not only single R. We have two R's. Right? We take here small r plus capital R square units. So, curved surface area of frustum of a cone is pi L into R plus R square units. When we talk about total surface area of a frustum of a cone, total surface area, curved surface area plus area of a small circle and area of larger circle. Right here, CSA of a frustum of cone, pi L into R plus R plus, what is area of this circle? Pi small r square. Pi small r square plus pi capital R square, because this radius is capital R. Pi capital R square. Then in these two, what is common? Pi L into R plus pi into R square plus capital R square. What is the total surface area of frustum of a cone? Pi L into R plus pi into R square plus R square. Now coming to volume. What is volume of frustum of a cone? Volume of a cone is 1 by 3 pi R square H. Similarly, we are going to calculate volume like this. 1 by 3 pi R square H. Pi R square H, how can we write? Pi into H into small r square plus small r capital R plus capital R square cubic units. 1 by 3rd pi H into R square small r square plus small r into capital R plus capital R square is the volume of frustum of a cone. In this, suppose you need to calculate slant height. How will you calculate? Same manner. How will you calculate here? Here only one R you have, but here two R's you have. So look here, L is equal to, L square is equal to H square plus R minus R whole square. capital R minus small r whole square. When you want only L is equal to square root of h square plus capital R minus small r whole square. These formulas also you should remember, children. Yes, let's have a recap of all this, children. Right? First solid is cube. When we talk about lateral surface area of a cube, it is 4a square. Total surface area 6a square. Volume of a cube is how much? A cube. Coming to cuboid, lateral surface area is 2 into L plus B into H. Total surface area 2 into LB plus BH plus HL. Volume LBH. Next solid, cylinder, right circular cylinder. CSA of a cylinder 2 pi RH. TSA of a cylinder 2 pi R into R plus H. Volume pi R square H. Right circular cone. CSA of a cone pi RL. TSA of a cone pi R into R plus L. Volume of a cone 1 by 3 pi R square H. Sphere. Next solid is sphere. What is the curved surface area of a sphere? 4 pi R square. Total surface area also 4 pi R square. When they ask only surface area, it is also 4 pi R square. Volume of a sphere. It is 4 by 3 pi R cube. Next solid is hemisphere. CSA of a hemisphere 2 pi R square. TSA of a hemisphere 3 pi R square. Volume of a hemisphere 2 by 3 pi R cube. Next solid is frustum of a cone. Here we have two radius. One is small radius R, small r and capital R. CSA of a frustum of a cone pi L into small r plus capital R. Total surface area of frustum of a cone pi L into R plus pi into R square plus capital R square. Volume of frustum of a cone 1 by 3 pi H into small r square plus small r plus capital R square. These are all the formulas you should remember perfectly to do this chapter. We are going to learn 3 more solids. Look here, children, you can see right circular hollow cylinder. Right circular cylinder we know. Then what is right circular hollow cylinder? You know, actually this is a right circular cylinder. Right? Hollow means let us scoop out this round circular region and remove that piece outside. It will be having a thickness. For example, where you can see this, water pipes with cement they make. Do you remember? Anyway, you have seen with cement water pipes will be having thickness. Will be having thickness here and water will be flowing inside the hollow region. Right? Then that is an example for right circular hollow cylinder. You can imagine that water pipes. Right? So, we need to calculate the curved surface area, total surface area and volume for this. What are the dimension we use here? It will be having two radius. From center to here, it is small radius. And from center to the circumference, outer circumference of a circle, it is capital R. Look here, this is inner radius and this is outer radius. You can write it as dimension small r is equal to inner radius and capital R is equal to outer radius. Okay, and H is the height of the right circular hollow cylinder. First thing we need to find here is curved surface area. Curved surface area of the cylinder. How can we find this? It is hollow. It will be having two curved surface areas. inner curved surface area and outer curved surface area. Look here, inner curved surface area and from here to here, outer curved surface area. See here, this cylinder will be having a thickness. You can see the thickness, and at the top and at the bottom, top one ring of thickness will be there, bottom one ring will be there, and this full complete curved surface will be having some thickness. You can see the shaded portion there. Curved surface area, it will be having two curved surface area. Inner curved surface area. CSA of a cylinder formula, it is 2 pi r h. Inner radius is small r. So I have taken 2 pi r h. Outer curved surface area. Outer means what is the radius from here to here? Outer means capital R. So you take it as 2 pi capital R h. Next, total surface area of a right circular hollow cylinder. Total surface area means what, children? Curved surface area, inner curved surface area plus top ring and bottom ring. Okay, we need to add these two now. Total surface area 2 pi r h plus 2 pi capital R h plus what we need to do plus here? Curved surface areas we have added. Then we need to add this ring and this ring. So 2 rings, you can write it as 2 times. 2 times you can write this. What is the formula for ring? Pi capital R square minus small r square. See here, this capital R square minus small r square will give the area of the ring. That can be written as 2 pi into r plus r into h plus 2 pi into r square minus r square. You can easily remember, children, this is the formula for total surface area of a right circular hollow cylinder. Coming to volume. What is volume of this right circular hollow cylinder? How do we get the volume of this right circular hollow cylinder, children? Understand here carefully. There is no bottom here. There is no bottom. So, how to calculate what is the volume of a cylinder? Pi r square h. And inside cylinder volume is small r, pi r square h. Outside cylinder volume minus inside cylinder volume will give the volume of the thickness, what you have shaded here. That means volume of a cylinder formula is pi r square h. So we have pi r square h, right? We take it as pi into capital R square minus small r square into h cubic units. So understand this carefully. Once again, let me repeat this one. Right circular hollow cylinder, inner radius, outer radius. Inside radius is smaller, outside radius is capital R. And height is represented by h. Curved surface area, when I talk, it has inner surface area, curved surface area and outer curved surface area. So both it will be 2 pi small r h, 2 pi capital R h. Coming to total surface area, inner surface area plus outer curved surface area plus top one ring of thickness you will be having now. This area plus bottom ring area you need. So 2 times ring area. Ring area how you are going to get? 2 times pi capital R square minus small r square. If you add all this, you are going to get this. That is 2 pi into r plus r h plus 2 pi into r square minus r square. Coming to volume, pi capital R square minus small r square into h. Let's see the next solid. What is your next solid? Hollow spherical shell. Hollow spherical shell. What is this? We know sphere. It is a solid sphere. Hollow sphere, how can you say? Looking sphere it is solid, but inside it is hollow. So let us imagine coconut. Yes, coconut is covered with a green shell outside. Inside coconut and water will be filled, right? So look here, hollow, water is not there inside. Just imagine a coconut without water. Inside it is hollow, right? It is a hollow spherical shell. We need to calculate the curved surface area, total surface area and its volume. Okay, look here carefully. I think I have shaded clearly, right? You cannot see any hole. From center to here, there is a coconut part. You imagine, just imagine. Imagine like this, children. The shaded part has a thickness. So inside radius is small r, outside radius is capital R. Here, when we talk, we can say small r is equal to dimension. Inner radius, capital R is outer radius. In the hollow spherical shell, outside what you can see, that is only the curved surface area and total surface area. What is the curved surface area of a sphere? 4 pi r square. It doesn't change anything for this. Same you will be having CSA and TSA will be 4 pi r square. Which r I need to take? We need to take outside r, that is capital R. 4 pi r square units is the surface area of hollow spherical shell. Same thing for CSA and TSA. Coming to volume. Volume, this I don't want. Volume of the shaded ring I want here. So what is the volume of a sphere formula? What is volume of a sphere? 4 by 3 pi r cube. Here you have two radius. Volume of complete hemisphere minus volume of inner sphere. That means 4 by 3 pi capital R cube minus 4 by 3 small r cube is your formula. So let's write here volume of this hollow spherical shell. 4 by 3 pi capital R cube minus small r cube. Cubic units is the formula for hollow spherical shell. Right? Let's go to the next one. What is your next one? Hollow hemisphere. Hollow hemisphere. Just you can remember some soup bowls. Okay, thick soup bowls you can remember. Or you can remember a broken coconut. What happened with the coconut you can see with the outer shell. Right? Inside it is hollow. You imagine this is a half-cut coconut. Now, this region and this shaded region, you can see here carefully. From here to here, small r. And from here to here, or you can write like this. From here to here, capital R. Right? Small r. Inner radius. Capital R. Outer radius. Now, curved surface area. Again, it will be having two curved surface area. Inner curved surface area and outer curved surface area. Right here. Inner curved surface. Inner curved surface area, or just you can write inner curved surface area. Inner CSA is equal to. What is CSA of a hemisphere? Sphere it is 4 pi r square. Hemisphere 2 pi r square. Which r will take? Inner, right? Small r. 2 pi r square. Outer curved surface area CSA is equal to 2 pi capital R square. Capital R square. Two curved surface area it will be having, inner and outer. Coming to total surface area. When we talk about total surface area, look here, inner, outer curved surface area plus this ring you need. Okay, plus this ring. That will be, let me write here, total surface area. I am writing 2 pi small r square plus 2 pi capital R square plus this ring. How you are going to get the area of this ring? That will be pi capital R square minus small r square. Only one ring it had, right? This one you can still write like this. 2 pi into r square, small r square plus capital R square plus pi into r square minus r square. Okay, this is the total surface area of hollow hemisphere. Coming to last one, it is volume. Volume of hollow hemisphere. Observe here children, it is hollow. Inside part it is hollow. Outside volume minus inside. How can we get this volume? Look here, this volume minus this volume, you are going to get this thickness volume, right? So volume of hemisphere is how much? 2 by 3 pi r cube. And this volume if you subtract, 2 by 3 small r cube. Subtract this one, that is only the volume. 2 by 3 pi capital R cube minus small r cube. 2 by 3 pi r cube, capital R cube minus small r cube is the volume for hollow hemisphere. Right children, these formulas are very important basic for this chapter, that is surface areas and volumes. Areas you know, CSA, total surface area, CSA plus area of top and bottom. Volume, the quantity inside the solid is called as the volume. So these all formulas are very important to do this chapter. Keep a thorough practice of these all formulas. Please don't by heart. Understand each and every formula, how we get the formula. Right? There are many application problems in this chapter. These formulas will help you a lot to understand the application problems. Right? With this, we are going to end our session today. In our next session, we are going to continue with the exercise problems. Until that, keep watching. Thank you all.